So today we're going to be looking at index laws. So these are really important. But before we look at the general rule, we're gonna derive it with some examples. So imagine I asked you to do a times a. Well, that's obviously just a squared. Imagine if I asked you to do a squared times a. Well, a squared is just a times a, and then times a again. So there's three a's there, so it's a cubed. What about a squared times a squared? Well, again, a squared is a times a, and then a squared is a times a. And we've got four a's there, so it's going to be a to the power of 4. So we can see when we're multiplying the same terms, whatever power they're being raised to, what we're doing is we're just adding the powers. Sorry, that's a 2. So a squared times a squared is 2 plus 2, we want a to the 4. And this is where that comes from, because whatever we're raising it to the power of, like whether it's 3 or 4 or 5, we're going to have that many of them. And then when we times it by the same term, whatever we're raising that to the power of, in this case it's 2, we're just going to be, again, just multiplying it by that. So basically we're just counting the number that we have. So that's why we're adding them. So you can say that a to the n times a to the m equals a to the n plus m. Okay, and it's the same thing if we wanted to do division, right? Let's say I asked you to do a to the power of 8 divided by a to the power of 5. Well, you know from cancelling that we can cancel that, and we're going to get a cubed. So a to the 8 divided by a to the 5 is a cubed, and it's the same thing. Whatever we wanted to do, a squared over a to the 1, those will cancel, and we'll just get a. So we can see, similar to multiplication, if we have a to the n divided by a to the m, that just equals a to the n minus m. So that's the rule. Don't just memorize it, right? Remember where it comes from. Okay, now let's imagine I asked you to do a cubed all squared. Okay? So what you want to do is you want to do a cubed times a cubed, because that's all we're doing when we square something. And then from what we just did, we know that that's a to the 3 plus 3, which is a to the 6. Okay, and it's the same. Imagine if we wanted to do a to the 2.5 and then to the power of 3. We would do the same thing. We'd have a to the 2.5 times a to the 2.5 times another a to the 2.5, and then adding those up, we're going to get a to the 7.5. And so again, we're seeing a general rule here. Our final answer in both cases is it's 3 times 2 for the top, and then it's 3 times 2.5 for the bottom. So that's kind of where this is coming from. We're going to see a to the power of n to the power of m equals a to the n times a to the n times a to the n, and then we're doing that m times. So there's m lots of these. And so from what we just looked at, if we did n plus n plus n plus n m times, it's going to give us nm. And so that's where this is coming from. I mean, don't just memorize the rule, a to the n to the m equals a to the nm. Think about where it's come from. It's the same reason that adding something multiple times gives you multiplication. If you did 3 plus 3 plus 3, etc. 10 times, you'd have 3 times 10. And we're doing the same thing, just instead they're just little numbers in the corner rather than actual numbers, but it's the same thing. If you raise something to the power, you're doing the addition multiple times, which is going to give you multiplication. So that's where this little rule has come from. Okay, let's imagine I asked you to do a to the 5 times a to the 0. That's a little bit weird. Like a to the 5, we know that's a times a 5 times. But what is a to the 0? It's tough to get your head around. But from what we just looked at, we're multiplying two a's together, so we know we can just add the powers. So that's just a to the 5 plus 0, so it's just 5. And so that tells us that a to the 0 is, well, what a to the 5 times a to the 0 is itself. So a to the 0 must equal 1, because 1 is the only, it's defined as the multiplicative identity. It's the only number, at least at this level, where if you multiply something by it, then you'll get the same number. So a to the 0 must be 1. So that's another rule. Anything to the power of 0 must be 1. And don't ask me what 0 to the power of 0 is. I don't know. Okay, so let's suppose I asked you to do a to the power of 6 times a to the power of -6. Again, it's a little bit confusing about what a to the -6 is, because it's not like you can times something by itself a negative number of times, or at least it's difficult to get your head around that. But from what we just looked at, we've got two ways. So we're going to be adding the powers, or in this case, multiplying or negativing the powers. So we've got a to the 6, sorry, you can't see that, a to the 6 minus 6. So that's just a to the 0. And if you remember, that's just 1. Since anything to the power of 0 is 1. And so we've got a to the 6 times a to the -6 equals 1. Well, so that just means a to the -6 has to be 1 over a to the 6, right? Dividing both sides by a to the 6. And so again, that's going to give us a general rule. It's not, again, these aren't proofs. Proves? This isn't proving anything. This is just showing you where it's really coming from, why we're defining these things the way we're defining them. Anything to the power of the negative n, so a to the minus n is 1 over a to the n. Okay, so now we're going to learn what it means to raise something to a fraction. Again, how can you multiply something by itself a fraction number of times? So a cubed to the power of 1 over 3, from what we just looked at, we're going to want to multiply them together. So 3 times 1/3 is just a to the 1, and that's just a. So what we want to ask ourselves is, what are we doing to a cubed to get us to a? Well, that's just, it's pretty obvious. We're just going to be taking the cube root of it. So in that sense, what we're doing when we raise something to a fraction is we're taking the nth power of it. So for example, if you had a to the 1 over n, that is just equal to the nth root of that. And so that's going to help us. Imagine if we wanted to do a to the 3 over 2. That's just a to the half cubed, right? They're the same thing. We multiply the powers. 3 times a half is 3 over 2. And that is just the square root of a, taking it to the half, and then cubed. So that's an idea of what we're doing when we raise something to a fraction. Like, what even is this? This is kind of what we're doing. Okay, so here's a summary of all the index laws. Again, I would encourage you not to just memorize them, but to understand where they come from and why they are what they are. In another video, we'll go over some examples to really cement your understanding. But if you have any questions, just let me know, and I'm happy to help.